In this set of lectures, we will talk about time value of money. After a brief introduction, we will go over the different possible interpretations of interest rates, talk about the concept of future value, both for a single cash flow and then a series of cash flows. Then we will talk about present value, again for a single cash flow and a series of cash flows. And finally, we will work on some problems which involve solving for rates, number of periods, size of annuity payments, and so on. A brief introduction. If you have $100 today versus an option to receive $100 after 3 years, so this is time 0, this is at the end of 3 years, what would you prefer? Obviously, you would prefer $100 today. Even though we have $100 in both cases, you prefer $100 today. This means that there has to be some value associated with time, because you are putting more value on the $100 that you are getting today relative to the $100 at a later point in time. The money today, or the value today, is called the present value. At times this could be an investment which you make at time 0. The value at a future point in time is called the future value. Let us say that you are indifferent between $100 today versus $110 after 1 year. This $110 is then referred to as a future value at the end of year 1. The relationship or the link between present value and future value is established through an interest rate. And what we are going to do in this reading is essentially talk about these concepts: present value, future value, and the way we link these two concepts using interest rates. The central theme is interest rates, so let's talk about the different interpretations of interest rates. Interest rates can be interpreted as, number 1, a required rate of return, or a discount rate, or a opportunity cost. Say you lend $900 today and receive $990 after 1 year. So if we put this on a timeline, time 0, you lend 900, so let's put a minus sign to indicate money out, and then after 1 year you get 990 back. The fact that you are willing to do this, you are willing to give $900 today on the condition that you get 990 after 1 year, means that to engage in this transaction you are requiring a return of 10%. I'm sure you can calculate this, given that you are lending 900 today or investing 900 today and getting 990 after 1 year, that interest rate is 10%. And the required rate of return interpretation is simply saying that you require a return of 10% to engage in this overall transaction. So that is the required rate of return interpretation. Discount rate is also straightforward, and we'll cover it briefly here and in a lot more detail later. But if you think of the money that you are getting after 1 year, which is 990, you can discount 990 at 10% to get the present value of 900, and therefore the 10% can also be thought of as a discount rate. And finally, opportunity cost. Let's say that you had taken the $900 and spent it on something else. What you have then done is you have foregone the 10% return that you might have received. And if you remember, the concept of opportunity cost is the cost of what you forego. In this particular case, what you have foregone is the 10% return. Therefore, 10% is also be thought of as a opportunity cost. We shift gears a little bit now and look at interest rates from an investor perspective. As an investor, we can think of interest rate as a sum of multiple components. The first component is the real risk-free interest rate. This is the rate that you get on a security that has no risk and is extremely liquid, and we make an assumption here that there is no inflation. We can then add on a inflation premium. Inflation premium is the expected annual inflation in the upcoming period. We can also then add the default risk premium. This is the additional premium that an investor requires because of the risk of default. And you can understand this through a simple example. Let's say that you lend some money to person A and also lend some money to person B. To both these people, you are lending $100 initially. If B has a high risk of default, so you are worried that B might not pay, then you might demand a higher return from B because of that risk of default. That additional return that you will demand from B because of the risk of default is called the default risk premium. Next, we have liquidity premium. This is the premium an investor demands because of the lack of liquidity of an investment. Here again, think of two investments, C and D, which are similar in all regards. The only difference is that investment C is liquid, extremely liquid, whereas investment D is not that liquid. Clearly, as an investor, we will demand a higher return on D because it is not liquid. That additional return that we demand is called the liquidity premium. And finally, we have maturity premium. The idea being that if you have two securities again, let's say E and F, E has a maturity of 1 year and F has a maturity of, let's say, 4 years. Because F has a longer maturity, it has a higher risk in terms of the price of F being more sensitive to changes in interest rate. And this is a concept that you will understand better when we do fixed income securities. But for now, you can just take it as a given that F has higher risk because of the longer maturity. And obviously, an investor will demand some compensation for that higher level of risk. So the sum of the real risk-free rate and the inflation premium is often referred to as the risk-free rate or the nominal risk-free rate. So if our real risk-free rate is 3% and the inflation premium is 2%, then the nominal risk-free rate is 5%. If you hear the term risk-free rate, then the assumption is that we are talking about the nominal risk-free rate. Let's look at a practice question. Jill Smith wishes to compute the required rate of return. Which of the following premiums is she least likely to include? The correct answer is C, nominal premium. And we say that because while this sounds like a nice term, but it is clearly not included in the list of premiums that you saw on the previous slide. It is possible that you'll see a question like this on the exam, so make sure that you know all the premiums really well. Next question. The correct answer is C. The required rate of return is the minimum rate of return. So A and B are correct options. C is not correct because of this. This is a mistake, and since we are looking for least likely true, C is the choice. Another practice question. Say you have 5 different investments and we have the maturities for each investment, the liquidity, default risk, and a interest rate for each investment. Why is there a difference between the interest rate on investment A and investment B? They have the same maturity, they have the same default risk, but interest rates are different. And the answer is because of the difference in liquidity. Does it make sense that the return on B is higher? The answer is yes, because B has lower liquidity, and therefore investors will demand a higher return for investing in B relative to investing in A. That higher return happens to be 0.5%. So in our simplistic example here, 0.5% is the liquidity premium. Next question is estimate the default risk premium. And before you go on, try to solve this on your own. If you look at investments D and E, notice that they are both 3-year investments. They have a different liquidity in the sense that D is high liquidity, E is low liquidity, default risk is different, and interest rates are different. What we need to do is make the liquidity the same. Let's say that D for some reason goes from high liquidity to low liquidity. Will that change the interest rate? The answer is yes. If the liquidity becomes low, then investors will require a higher return. And we've already determined that the liquidity premium is 0.5%. So we add 0.5% and we have 3.5% as our return. Then what we can do is the following. If we have this newer version of D, let's call it D bar or D complement. So this has a low liquidity versus E, which also has low liquidity. Default risk here is high. The difference between this new version of D, which is the low liquidity version, and E is 1.5%. The difference between the new version of D and E is 0.5%. This means that the default risk premium is equal to 0.5%. And finally, can you calculate the upper and lower limits for the interest rate on investment C? Notice that between B and C, the only difference is that C has a longer maturity, which means that the interest rate on C must be greater than B. So we can say that R has to be greater than the return on B, which is 2.5%. So R has to be greater than 2.5. And if you look at the low liquidity version of D, that has a return of 3.5%. Other than that, it is similar to C because liquidity is the same, default risk is the same. So maturity is less. So maturity for investment C is less than the maturity for investment D. That means that R has to be less than 3.5. So the range for R has to be between 2.5 and 3.5. Moving now to the concept of future value, and we will start with a simple case where we look at the future value of a single cash flow. The future value at time n is equal to the present value into 1 plus R, which is the interest rate, to the power of n. Say the present value is 100. So at time 0, the value is 100. The interest rate is 10%. What is the future value after 1 year? If you plug into this formula, what you see is the following. The present value is 100, R is 10%, and in this formula we will use the decimal. So 1 plus 0.1 to the power of 1. This is equal to 110. So after 1 year, 100 will compound to 110. What about at the end of year 2? Again, from the formula, we have 100 into 1.1 to the power of 2, and this is 121. So at the end of 2 years, we have 121. We can say that FV2, future value at the end of year 2, is 121. Notice the following. If we only had simple interest, where 100 is invested, then in year 1 the interest would be 10, in year 2 the interest would be 10, and at the end of 2 years we would have 120. So why is there a difference between 120 and the future value of 121 that we have calculated using this formula? The answer is because of compounding. What has happened is, at the end of year 1 we have 110, which is the original 100 plus the $10 interest. That entire amount, the $100 and the $10 interest, is being reinvested for the second year. So in our compounding scenario, even the $10 is receiving interest, and it is the $1 interest on these $10 that is giving us the extra $1 over here. Let's see if you can do this practice problem now. This is fairly straightforward, and here is what you should have done. So recognize the formula that we just saw. Future value is present value into 1 plus r to the power of n. So n here is 2.5. You plug in the numbers and that is what you should get. Let us now learn how to use the financial calculator, and then we will do a future value calculation using the calculator. The first time you use your calculator, and we'll talk here about the Texas Instruments BA2 Plus, you need to set the floating decimal. And what that means is, when you set to floating decimal, the calculator automatically gives you the appropriate number of decimal places. So you hit the following keystrokes: second, which is right here; format, which is over here; and then enter, which is here. And then you will see the option to enter the number of decimal places. You enter 9 and the display is going to be 9. Then you hit second again and quit. That will return the calculator to standard mode. What you have now done is set decimal places to 9, which represents a floating decimal. Let's work through this problem now. You invest $100 today at 10% compounded annually. How much will you have in 5 years? You have learned how to do this using the formula, but now we'll see how to solve this problem using the calculator. And we are going to use this set of functions, which represents the time value of money functions on the calculator. Here is what you do. Second, quit, just to set the calculator in your standard mode. And then second, clear time value of money. This clears the time value of money worksheet. If you don't do this, then the calculator remembers what you did last time. Then you hit 5n. N stands for the number of periods. In our particular case, we have 5 years, which means that n is equal to 5. 5n, and the display then will be n is equal to 5. Then you say 10 IY. So this is saying that the interest rate per period is 10%. Notice that here you are entering the percent, as opposed to the formula earlier where you entered a decimal. Then you enter 100 and PV. This is saying that the initial investment is 100. 0 payment, that means that over the 5-year period, time 0 to time 5, in between you are not making any payments. So this is 0. And then you compute the future value. That will give you this number. We have a minus because the calculator assumes that the future value will have the opposite sign relative to the present value. If you put in plus 100 here, then at the end of 5 years, the calculator assumes that you are taking the money out, so it will give you minus 161. If during entry you had put in minus 100, then the calculator would give you plus 161. We'll now talk about frequency of compounding. What we have done so far is talked about compounding once a year, but compounding of interest can happen more than once a year. Say you invest 80,000 in a 3-year CD. This CD offers a stated annual interest rate of 10%, compounded quarterly. How much will you have at the end of 3 years? How many periods do we have in this case? 3 years, and in each year we have 4 quarters. So the number of periods is equal to 3 times 4, which is equal to 12. What is our initial investment or present value? That present value is 80,000. What about the interest rate? If we are using 12 periods, then we need to look at the interest rate for each period. The stated annual rate is 10%, which means that the interest rate per period must be 10 over 4, which is 2.5. The payments here are 0. You can then simply compute the future value. The answer you should get using your calculator is 107,591. You could also solve this problem using the formula, and the way you think of that is as follows. Your future value at the end of 12 periods, remember 3 years means 12 periods in this example, is equal to the present value, which is 80,000, into 1 plus the interest rate. Now the interest rate has to be the interest rate per period, which is 0.1, that's the 10%, divided by 4, because we have 4 periods in a year, and then raised to the power of the number of periods, which is 3 years multiplied by 4 periods per year. And when you do this calculation, you should get the same answer. Let's see if you can solve this problem. The correct answer is B. What we have done here is shown the working using the formula, but you could have done this also using your calculator functions. And just to make sure you've understood the calculator function well, let us do it together. The number of periods here is equal to 365. Why? Because we just have 1 year, but we are assuming daily compounding. So every day is a period. The interest rate that you will have to plug in is equal to 4%, which is the stated annual rate. We put this in as 4% divided by 365. That's your return per day. And then the present value is equal to 3 million. The payments are equal to 0. And the future value is what you have to compute. If here is what you should get. Moving now to continuous compounding. We have seen an example with annual compounding. Then we talked about quarterly compounding. We have also seen daily compounding. If we keep increasing the number of compounding periods until we have an infinite number of compounding periods per year, then we say that we have continuous compounding. The formula for continuous compounding is given right here. The future value at the end of n years, now keep in mind this is the number of years, is equal to present value into e, this is the mathematical number e, to the power of r, where r is the stated annual rate. It is also sometimes called the continuously compounded rate, multiplied by n, which is again the number of years. An investment worth 50,000 earns interest that is compounded continuously. The stated annual interest rate is 3%. What is the future value of the investment after 3 years? Using the formula, the future value at the end of 3 years is equal to 50,000, which is the present value, multiplied by e, which is right here on your calculator, that is really e to the power of x. So into e to the power of r. R is the stated annual rate expressed as a decimal. So 0.036 multiplied by the number of years, which is 3. So the way you do this on your calculator is as follows. First thing, just multiply 0.036 into 3, then hit the second button and e to the power of x. That will give you an expression for this. and then multiply by 50,000. When you do the calculation, here is what you should get. Here is an important concept building exercise. Assume that the stated annual interest rate is 12%. What is the future value of $100 at different compounding frequencies? And then what is the corresponding return? I'll do the first one for you. If you have annual compounding, then at the end of 1 year, $100 must become 112, which means that the return is 12%. What if you have semi-annual compounding? Will the return still be 12% or more than 12%? Hopefully you recognize intuitively that the return will be slightly more than 12%. And given what you've learned over the last few minutes, I want you to fill this table out before you move on. If you've done things correct, here is what you should get. Notice that as we compound more often, the future value becomes a little bit higher. When we get to daily versus continuous, the number is almost the same. If you go to the third decimal place, then you will notice that the return using continuous compounding is a little bit higher, but at 2 decimal places, it is essentially the same. So the return keeps getting better as we compound more often, but it doesn't become a lot better. Note also that if you have 2 banks, A and B, Bank A tells you that they will give you a return of 12.5%, but there is only annual compounding. Whereas Bank B gives you a return of 12% and the return is compounded daily. What is better? Even though 12.5 looks higher, but you know that if your return is stated as 12% but then is compounding continuously, effectively you are going to get a return of 12.75%. So the offer from Bank B is actually better than the offer from Bank A. And this brings us to the concept of stated versus effective rates. In the example that we just saw, the stated rate was 12% across the board, but the effective rate depends on the number of compounding periods. When we have discrete compounding, then the effective rate is calculated using this formula. Let us do this for one of the scenarios. The effective annual rate is equal to 1 plus the period rate. Let's say that we are doing quarterly compounding. Then the periodic interest rate is equal to 12, which is 0.12 divided by 4. So that would mean that the periodic rate is 0.03 or 3%. We raise this to the power of m, that's the number of periods in a year. If we have quarterly compounding, that would be 4, and then minus 1. A lot of people get confused about this minus 1, and the idea is actually fairly straightforward. If you look at this part of the expression, essentially we have 1.03 to the power of 4, which is telling us how much $1 will become at the end of 4 periods, each period being a quarter. $1 is going to become 1.1255, but this is not a rate. To figure out what your return is, you need to subtract the original $1 that you invested, and what you are then left with is 0.1255. So that is your effective return, and expressed as a percent, this is 12.55%. If we do continuous compounding, then the effective annual rate is e to the power of r. R is the stated rate of 12%. E to the power of 0.12 minus 1, and when we do this we should get 1.1275. that's the e to the power of 0.12, and in case you're not familiar with this on the calculator, you plug in 0.12 and then second and then e to the power of x. That will give you this number, minus 1, which will give you this number, which is the return expressed as a percentage, that is 12.75. Moving now to the future value of a series of cash flows. And first, let's just understand some terminology. An annuity is a finite set of level sequential cash flows. Level means equal, and sequential means that the cash flow is happening at equally spaced points in time. So an ordinary annuity is one type of annuity where the first cash flow occurs one period from today. Let's say that you receive $100 one year from today, another $100 2 years from today, and then another $100 3 years from today. So this is an annuity. The payments are level because you are getting $100 each time. They are sequential. You are getting payments at 1 year periods, and the first payment is 1 year from today, which means this is a ordinary annuity. With the annuity due, the first cash flow occurs immediately. So if you have 100, 100 and 100, this is a annuity due. A perpetuity is a set of level, never-ending sequential cash flows with the first cash flow occurring one period from today. Here is an example of a perpetuity. The first cash flow is happening one period from today, and then every year you receive $100, and this goes on forever. Let us now calculate the future value of an ordinary annuity. Say you have an ordinary annuity with A equal to 1000. A refers to the annuity payments. In this particular case, we have 1000 over a 5-year period. The interest rate is 5%. We have 5 years. And what we are asked to calculate is the future value at the end of year 5. The brute force way of doing this is to simply take each cash flow and see how much each of these will be worth at the end of 5 years. This cash flow of 1000 at the end of 5 years is obviously 1000 at this point in time. The 1000 that you receive over here will be compounded one period. So this would be 1000 into 1.05 compounded once. This is going to be 1000 into 1.05 squared. This is going to be compounded 3 periods. This is going to be compounded for 4 periods. You take all these numbers, this, the number that is compounded for 3 periods and 4 periods, and you add them up, and what you should get is 5525.63. There is a formula that allows you to calculate the future value, and actually on the next slide I'll show you how to do this on the calculator, which is what you should be doing on the exam. But here I'm just introducing the fact that there is a formula, and at times you can get something called a future value annuity factor. So let's understand what this means. We have the same annuity. Each payment is 1000, interest rate is 5, n is number of periods is 5. So same scenario. The future value at the end of year 5 can be expressed using this formula. A is 1000, and then 1 plus R, 1.05, this is the interest rate, raised to the power of 5, minus 1 divided by the interest rate, which is 0.05. This number in here is called the future value annuity factor. If you do the calculation, you should get 5.5256. So this is the future value annuity factor. To come up with the future value, you take the annuity payment 1000 and multiply it by the future value annuity factor, and you will get 5525.6, which is the same answer that we got on the previous slide. On the exam, if you are given the annuity number and the future value annuity factor, you simply need to multiply the two numbers to get the future value. And finally, let's see how we do this using a calculator, and this is the method that you should use on your exam, we plug in n equal to 5, that's the number of periods. The interest rate per period is 5%, so plug that in. Present value is 0. That's because you are not making any investment at time 0. The first cash flow is happening 1 period from today. The payment is 1000. That's the equal payment happening at the end of every period. And then you compute future value, and the answer that you should get is the same as what we've seen on the previous two slides. You should get 5525.6. And again, this is what you should do on the exam, because this is the fastest method and doesn't require you to memorize the annuity formula. Now I want you to work through practice question 6. So either you can use the formula and get this answer, or what you can also do, and the recommended method, is to use the calculator. So let's look at what we will plug in the calculator. Notice that she is depositing 24,000 a year for 15 years. So n is equal to 15. We are told that the interest rate is 12%. So I is equal to 12%. The present value is 0 because nothing is being invested at time 0. The payments are equal to 24,000, and then we compute the future value. When you do this computation, what you should get is 894,713. Try to solve this practice problem now. The correct answer is C, and if you think about it, we are given the annuity, so the A is given, which is essentially the payment, and if we know the future value annuity factor, which is 21.664, then to come up with the future value, all you need to do is multiply 120,000 by this. You don't really need to use the interest rate. So in terms of least likely, the best answer is C. How do we deal with unequal cash flows? And this is a fairly straightforward concept. We want the future value at the end of year 5. Let's say that the interest rate is 10%. The way you need to do this is individually compound every cash flow, and this connects with the brute force method that we talked about at the start of this segment. So if you draw your cash flow, this is time 0, 1, 2, 3, 4, 5. This is your timeline. We have $1,000 at the end of year 1. So this is going to be compounded for 4 periods. So this will become 1000 into 1.1 to the power of 4. Then you have 2000 at the end of the second period. This will compound 3 periods. So 2000 into 1.1 to the power of 3. And then 3000 from here. This is compounded 2 periods. So 3000 into 1.1 to the power of 2. 4000 is going to be compounded just 1 period, and the final 5000 at the end of year 5 is what you have. So add all these numbers, that is your future value at the end of year 5. When you do the calculation, what you should get is 17,156.1. So that is it in terms of the first lecture in the series on time value of money. In the next lecture, we will talk about the concept of present value.